Welcome again to this presentation. It will be a short presentation. We are starting on question 28. Remember last time we ended on question 27. We are still in the series of acid-base reaction, question and the answers. Let's see. 28 is saying, what is the concentration of ammonium ion, ammonia, and hydroxide and H plus in a salt formed by the 500 ml of 0.2 nitric acid and 500 ml of 0.2 molar ammonium hydroxide. Then they are saying calculate also the pH of the salt formed. The Ka for ammonium was given as 5.6 times 10 power negative 10. Here we don't have the concentration of the salt which is formed. What we know is that they have taken the nitric acid, which is an acid, and they have reacted with ammonium hydroxide, which is a base, and then they form a salt, and then they are asking what will be the concentration of the ammonium, ammonia, hydroxide, and H plus. They're also asking what will be the pH of the salt which is formed. What we need to do is just to know the concentration of the salt which is formed. Let's see. Now here, that is what will happen. We have the nitric acid which reacts with the ammonium hydroxide to give this salt, ammonium nitrate plus water. That means this is the salt that will be formed. And this salt, what will be its concentration? We need to check how many moles of nitric acid and ammonium hydroxide have reacted. We have more of nitric acid, that means it will be 0.2 times 0.5. This is 0.2, it will be the molarity times 0.5, that is 500 milliliter that we have converted to liter, then you get 0.1 mole. We have also the moles of ammonium hydroxide, so also we have 0.2 mole per liter times 0.5. If we convert 500 milliliter to liter, in this case we get 0.5. Also we see that the acid and the base, they react at 1:1 mole ratio. That means the concentration of the salt which will be formed will be equal to the moles of the salt that will be formed will be equal to the moles of nitric acid or the mole of ammonium hydroxide, because the mole are reacting as 1:1 ratio. So then we say mole of nitric acid is equal to mole of ammonium hydroxide, which is equal to this one. That means we have the ammonium nitrate. But in its solution, this will not be as a salt, it will be ammonium ion and nitrate. Then we can calculate the salt, because they are saying the salt that will be formed, there's moles, 0.1 mole, there will be in a total volume. The volume here we have 500 milliliter plus 500 milliliter. That means a volume of 1 liter. So here we have the concentration of the salt that will be formed is equal to 0.1 mole of the salt dividing with the volume of 1 liter, then you get 0.1 mole of the salt. But that salt, I told you that we will not get in the solution. The salt will give different ion. It will be having the ammonium ion and the nitrate in the solution. So the salt formed in water will give this one, ammonium and nitrate. This is the spectator ion, but this one is going to dissociate. So ammonium is a conjugate acid from a weak base, because here we have a nitric acid which is a strong acid and a weak base, ammonium hydroxide. Then this ammonium is a conjugate acid from a weak base. That means it will dissociate, giving out a proton. So that is what will happen. It will not be stable. It will dissociate to give the ammonia and to give the proton. Then we can use the IC table to determine the concentration of ammonium, the concentration ammonia, and the concentration of H plus. And after getting the concentration of H plus, then you can get the concentration of hydroxide. So we use here the IC table. Here we have the ammonium, here we have the ammonia, and we have the H plus. The concentration of ammonium will be equal to the concentration of the salt that we have calculated as 0.1 molar. Then here initially we have 0, here we have 0, and here the reactant are getting removed, negative x. Here we are forming the product plus x. Then at equilibrium, this is what we have 0.1 minus x. Here you have x, here you have x. That means the Ka will be equal to x, this one times this one, which is equal to x squared over 0.1 minus x. So we can make the denominator, the x in the denominator negligible. In this case, we have the Ka is equal to x squared over 0.1, and we can do rearrangement to find that the x will be equal to square root of 0.1 times the Ka. X will be equal to 7.5 times 10 power negative 6 molar, and x is equal to the concentration of hydrogen. So we can check whether our assumption is valid by calculating the percentage dissociation. We see that the percentage dissociation is less than 5%. That means the assumption is valid. So we have the concentration of H plus equal to the concentration of ammonia equal to X, and it is equal to 7.5 times 10 power negative 6. Now what will be the concentration of ammonium? We take 0.1 minus X, that means 0.1 minus 7.5 times 10 power negative 6, we get 0.1 molar. So we have also the H plus. Here we have in the table, we're having the H plus. This is the hydroxide. Then it's equal to 10 power negative 14 dividing with the H plus. This is not the H plus, that's the hydroxide. Here, please, can you plus here the hydroxide, not H plus. Here, this is hydroxide. Hydroxide is equal to 10 power negative 14 dividing with H plus. So in this case, we have the hydroxide is equal to 1.34 times 10 power negative 9 molar. So then the pH, that will be equal to negative log of H plus. This is the H plus, that means negative log of 7.5 times 10 power negative 6. Then you have 5.125 as the pH. That was question 28. Let's go to question 29. Question 29 is saying we have calculated the concentration of sodium, acetate, ion, hydrogen, and hydroxide for a salt solution of 0.1 molar sodium acetate. Here we have the salt. We can immediately do the IC table because we have sodium acetate. In the solution, it will give sodium and the acetate. So now they are asking, what is the concentration of sodium? Of course, the concentration of sodium will be equal to the concentration of sodium acetate, and it will be equal to 0.1. Again, acetate is a conjugate base from a weak acid. Here it is a conjugate base from weak acid. In this case, it will take a proton. By taking a proton, it will give the acetic acid plus hydroxide. Then you can use the IC table to solve the issue, the X, the dissociated amount of hydroxide. Here we have 0.1, here you have 0 minus x, 0.1 minus x, here you have x, here you have x, and then you have the Kb is equal to x squared over 0.1 negative x. Because here we are having the Kb because it is a conjugate base from a weak acid. Then if we can solve the equation, so we can find for Kb, and then we can solve for x, then we can say Kb also was not given, they gave us only the Ka. So then to calculate the Kb, we take 10 power negative 14 dividing with the Ka, then you get Kb. And now assume x as negligible, so we get that the x is equal to square root of 0.1 times Kb. Then x is equal to this one, 7.46 times 10 power negative 6, that is the hydroxide. That means hydroxide is equal to acetic acid is equal to 7.46 times 10 power negative 6 molar. Then what will be the acetate ion? It will be equal to 0.1 negative this one, we get 0.1 molar. Then the H plus will be equal to 10 power negative 14 dividing with the hydroxide, then we get this amount of H plus. So this is how the table looks like. That means the acetate will be equal to 0.1 negative x. This one will be to x, and hydroxide will be equal to x. And you have determined the x. Let's end on question 30. Let's end today on question 30. Question 30 is saying a 50 centimeter cube of 1 molar HCl is reacted with 30 centimeter cube of 0.7 molar sodium hydroxide. Then they are saying what will be the pH of the resulting solution. Here we need to check how many more of HCl and how many more of sodium hydroxide they are reacting. Of course, we have 1 more molarity, which is the mole per liter. We need to convert the volume in liter. How do you convert centimeter cube to liter? We divide with 1,000. Then we will get 0.05 liter. Then we multiply with the molarity, then we get 0.05 mole for acid. What are the moles of hydroxide? The moles of hydroxide, sodium hydroxide, will be equal to 0.03. That is 30 centimeter dividing with 1,000, you get 0.03 liter. Then we multiply with 0.7 mole per liter, we get 0.021 mole. Now what will be the remaining mole? It will be the moles of acid will remain. So here remaining number of mole of acid, we take 0.05 minus 0.021 equal to 0.029 mole. Then we can determine the concentration of the remaining HCl, but it will be in the total volume. In this case, we add 50 plus 30, we get the concentration of remaining HCl as 0.3625. It is this concentration of remaining HCl which will determine the pH of the solution. That means the pH will be equal to negative log 0.3625, then we get 0.44 as the pH of this solution.